Hi guys, today we're going to start with organic chemistry, alright? So this is the study of compounds that we find in living organisms. And in high school, we limit our focus to only a few of them, right? So let's just jump right in, and we're going to start with the first kind of organic molecule that you come across, alright? And that's alkanes. Okay, so what is an alkane? Alkanes are organic molecules that are only made up of carbons, hydrogens, and we only have single bonds. So, just to give you some examples of what that looks like, okay, the simplest alkane you can get is methane, called methane, and that has one carbon. And if you remember from your grade 10 chemistry, a carbon can form 4 different bonds because it's got 4 valence electrons. So we form a bond to one hydrogen over here, one hydrogen over here, and one hydrogen over here, and another here. Okay. And as you also recall, hydrogen only has one valence electron, so each hydrogen can only form one bond. So if we take a look at what we've got here, we've got a carbon that's made 4 bonds. It's got 4 valence electrons. Hydrogen has made one bond each. They each have one valence electron. Okay. Right. So that's the simplest kind of organic molecule, and that's methane. So now let's just go into some more examples of organic molecules. So organic molecules with 2 carbons are called ethane. So that means we've got a carbon here and a carbon here. So what happens is we've got a bond between the carbons, and then each carbon can now form 3 additional bonds, right? So, and those bonds are formed with hydrogen atoms. Okay. Right, and then of course, as you've seen, we've now had 1 carbon and 2 carbons, so next we'd expect to see a third carbon, right? So let's just take a look at what that looks like. Okay, and then again, if you check each carbon, you'll notice that there are 4 bonds for each carbon. So this one, we've got 1, 2, 3, 4 bonds. Let's check the next one. Again, 1, 2, 3, 4 bonds. And let's check our third one. We've got 1, 2, 3, 4 bonds. Okay, so that's quite an important check to perform anytime you're naming anything or drawing any organic molecule. You want to check the number of bonds. So let's get into our rules that we use for naming and drawing alkanes. Okay, so the first thing is we look at the number of carbons that we have. Okay, if there's only 1 carbon, we use the prefix meth. Okay, so just an easy way for you guys to remember this is only 1 me. So 1 me. 1 carbon is meth. Next, 2 carbons is eth. Okay, so that's the prefix that we have. So one way to remember this is it's either or. That's comparing 2 options. So 2 carbons is eth. Okay. Then we get 3 carbons. And 3 carbons is Prop. Okay. Right. So these first three are quite irregular, I suppose. You would not have really come across this as yet. And then from the fourth one, we now have but, so B-U-T. Alright. And then from there on, it becomes a lot simpler, because then we use numbers as we would with polygons in maths. So if we've got 5 carbons, it is now pent. So that comes from a pentagon, right? A 5-sided shape. And if we've got 6 carbons, it's hex, as we would in hexagon. And 7 carbons is hept, as it is in heptagon. And 8 is, I'm sure you guys have guessed it, oct, as in octagon. So these are the prefixes to alkanes, so it's the first part of the word. Now let's go to what comes at the end. Right, so at the end, what we have is, you will hopefully have guessed this one, we have ane, right? So we start an alkane, so at the end we have ane. So for so if it's an organic compound with 1 carbon, we'll call it methane. So it's meth, because it's got the 1 carbon, and what comes at the end? Ane. Okay. 2 carbons. What was our prefix there? It was eth, right? For either or. And then we're ending in ane again. 4 carbons was but. And you've guessed it, ends in ane. And just to see the rest, by 5 carbons is pent, right? And what does it end in ane? And then it looks like we have skipped the third one, and what would that be? I'll give you just a second to think, and then you can see if you get this one right. Okay, so again, it's an alkane. We know it's going to end in ane, and first letter was, or first part of the word, our prefix, propane. Right. So those are just some of the examples. You can refer to a full list in our PDF document. All right. And you of course can refer to any other resources you have, like your school textbook or your class workbook. Okay. So that was the first type of organic molecule that we'll be studying, alkanes. Let's move on to the second one. Right. So the second type of organic molecules or that we study are called alkenes. Okay. So as you've now seen, we had alkanes and now we've got alkenes. The word for these general groups of molecules is called homologous series. Okay, so all the alkanes form a single homologous series, and as we'll see now, our alkenes will form another homologous series. Okay, but now what is the difference between alkanes and alkenes? Difference is between 2 of the carbons that'll be in our alkenes will have a double bond formed. So that means 2 bonds instead of the 1, right? So now you already would have guessed some things about this. So because we have to have a double bond between 2 carbons, the smallest alkene must have 2 carbons. So we can't have a double bond between 2 carbons if we only have 1 carbon, obviously. So smallest alkene must have 2 carbons. Next, we can introduce some more terminology. So how do we identify the difference between alkanes and alkenes? Alkenes, we look for this double bond, and alkanes, we just make sure everything has a single bond. That we can refer to as our functional group. So for alkenes, this is our functional group, this double bond between two carbons. Okay, so it's just a single double bond, that's all, and that's all what we are left with. But with alkanes, what we get is we only have single bonds between the carbons. Alright, so sometimes you will see in textbooks they refer to this as the functional group. Obviously you can have a single carbon alkane, so it's not necessarily the general case, but ultimately all you're going to look for is, do we only have single bonds? Do we only have carbons and hydrogens? Alkenes, do we only have one double bond? And do we only have carbons and hydrogens? Right. So let's go back to our alkenes and look at some examples. So again, we can have two carbons in alkene, and what do you think our prefix is going to be? It's going to be exactly the same as with our alkanes. We're going to have eth. If we had 3 carbons, again, we're going to have prop as our prefix. And 4 carbons would be bute, 5 would be pent, and so on. Right, so let's just do a quick recap. So smallest alkene we have as 2 carbons, prefix for 2 is eth, 3 is prop, 4 is bute, and 5 is pent. Okay, but now because they're alkenes, they're going to end in ene. So ethene, propene, butene, and pentene. Okay, now with alkenes things do get a little more complicated. Alright, so just to take a look at some of these molecules, just so that we can see what's going on. So if we have ethene, we know we've got our 2 carbons over there, and they've formed 2 bonds with each other, which means each carbon can only make 2 additional bonds. And we're going to bond 2 hydrogens. Okay. So far, so good. Nothing complicated. Now, let's take a look at propene. So now we're looking at 3 carbons. Okay. So what needs to happen is we need to have a 3rd carbon being bonded here. Alright? Which means that we need to form an extra bond between carbons. So where would that bond go? It would be over here. But obviously, seeing as each carbon can only make 4 bonds, that means that our carbon over here can not have this hydrogen bond, or this bond to the hydrogen atom anymore, because it instead is bonded to another carbon. Okay, so far so good. So we could have the double bond over here, or we could have had it on this side instead and had a single bond where the blue circle is. But either way, it would be the mirror image, and so it would be identical. Now let's take a look at butene. Okay, so how many carbons in butene? Let's see if you remember. Sorry, just give me 1 second. right. Okay. Right, so we'll just take a look at butene. So butene has 4 carbons, as we said. Okay, 2, 3, 4. So we know we need to form a double bond between carbons. So let's take the first 2 carbons in our molecule and make a double bond there, and then the remaining carbons will form single bonds with each other. Right, we can now draw in our hydrogen atoms. Okay. Don't forget over here, we've already formed our 3 bonds, so we can only make one additional hydrogen bond to a hydrogen. And then here we form 2, so we can make 2 bonds, 2 hydrogen atoms. So let's consider the various positions our double bond can be at. So we could have it over here as drawn, or over here. But once again, even if we had it over here in the red circle, it would be identical, as it would still be on the end carbon on the other side. And so we would have the same thing because it is the mirror image. But if we had it over here in the middle, it wouldn't be the same. So it wouldn't be the mirror image anymore. So now we've got something slightly different. So what it is necessary to do then with alkenes is indicate the position of the double bond. In this case, we have the double bond between this carbon and this one, and so we would number it from left to right. Had the double bond been where the red circle is, we'd number it from that side. Okay, and by numbering it, we can now label which carbon is bonded to, or which is the first carbon to be bonded to to be forming the double bond. So in this case, it's carbon number 1. So here, instead of simply just calling it butene, we would call it bute. Leave a dash over there. 1-ene. So 1 showing that the first carbon is a part of the double bond. Alright. Okay. Now we're going to take a look at what would have happened if it had been on the between the middle 2 carbons instead. So let's say we had our double bond over here. What would our story be? Okay. So now if we take a look, it's here in the middle. So if we started numbering from this end, it would be 1, 2, 3, 4. If we went from this end, it would be 1, 2, 3, 4. So going from left to right, the first carbon that is a part of our double bond would be the second one. From right to left, it is also the second one. So in this case, we would call it but2-ene. Okay, showing that the second carbon takes part in our double bond. And then of course, just when drawing it, what we always have to check, that we have in fact made 4 bonds for each carbon. So if we take a look here, we've only got the 3 bonds, so don't forget to fill in the additional hydrogen atom. Over here, we've got 4 bonds. So on the second carbon, we've got 4 bonds. We are happy. On the last carbon over here, we've also got 4 bonds, so we are happy. But on the third carbon over here, we've got 5. So we've got 1 too many bonds. So we will simply just leave out one of the hydrogens. And now we can confirm that each carbon has formed 4 bonds, and we're happy with what we've got.